Alright, in this third video on determining volume by slicing, we're going to be looking at a modification of the disk method called the washer method. And the washer method is used when there is a gap, or sometimes it's called a cavity, between the region to be rotated and the axis of revolution. So what that would look like is we'll have a function big R of x and a function little r of x, and we'll be going from A to B. So here's the region that we're going to rotate, but you notice that we have a cavity right here. So we have a cavity or gap between the region and the axis of rotation. So we're going to rotate this around the x-axis. Okay, so go ahead and kind of draw that in there, and so you see that we do have a washer. Okay, so we have a washer, you have the hole right there. And so what we're going to do is we're going to use the disk method twice. Okay, we're going to use the disk method to find the area, or not the area, but the volume of just the whole thing. Volume of the whole thing. And then we'll drill out the hole, and then we'll find the volume of the washer hole. And we'll subtract that. Okay, so here's your inner radius. And here's your outer radius, and this is how I determine the inner and the outer radius. The inner radius is going to be from the axis of revolution to the outer, to when you first hit the region. So inner radius is from the axis of revolution until you hit the region, and then the outer radius is going to be from the axis of revolution to the outer edge of the figure. Okay, so inner radius to the inner edge, outer radius to the outer edge. Okay, so when we put that in, that's going to be the volume is pi, and then we just combine it. So it's the integral from A to B. Okay, and there's the upper radius squared minus the lower radius squared, and that does exactly what we want it to do. So, oops, went too far. It finds the volume of the whole thing and then subtracts from it the volume of the washer hole. Okay, and then over here I have an image from OpenStax, and just another image. Maybe it looks a little bit better than mine, but again, you can see your inner radius and then your outer radius there. Okay. Alrighty, so we're going to take the same region and we're going to do two different rotations and get a little bit of practice in. Okay. So we're going to find the volume of the solid formed by rotating y equals x squared bounded by x equals 0, y equals 0, x equals 3, and we're going to rotate it in part A around the horizontal line y equals 10, and in part B around the vertical line x equals 5. So we're going to go ahead and sketch in our parabola. Okay. So I'm just going to do a rough sketch here. So we're going to go all the way up to 10 on the y-axis. There's x squared. I'll go ahead and shade in the region there. So that's the region to rotate. We're going to rotate it around the horizontal line y equals 10. Okay. And so what we're going to do is we're going to determine our inner and our outer radii. Okay, so you're going to start from the axis of revolution until you hit the edge of the region there. Okay, and so that is your inner radius. Okay, now determine your inner radius. X squared is this distance here, etc. That's x squared. So if we want to find this right there, what we're going to do is the whole distance is 10, and then we're going to subtract that 1 over x squared. Okay, whole distance is 10, and then subtract out the 1 over x, subtract the x squared. So there's your inner radius. Inner radius is going to be 10, and then subtract the x squared. Now the outer radius, so we hit the outer edge of the figure. Notice that it is flat. So it is flat right here, and that distance is 10 the whole way. So it's just constantly 10. So the outer radius is 10. Okay, and we're perpendicular with the x-axis and also y equals 10, so our functions need to be in terms of x. So the volume is going to be pi limits of integration on the x-axis, 0 to 3. Upper function minus the lower function squared individually. Okay, so it's going to be pi, integral from 0 to 3, 100 minus 100 plus 20x squared minus x to the fourth dx. So it's going to be pi, and then 20 over 3 x cubed minus x to the fifth over 5, evaluated from 0 to 3. So it's going to be pi, and then we have 180 minus 243 over 5. If we get a common denominator of 5, that's going to be 657 pi over 5, which is approximately 4 point, a little bigger than 412.8 units cubed. Okay? All right. Now we're going to do the part B, where we're going to rotate around the vertical line x equals 5. So we're going to rotate around the vertical line. You're going to be perpendicular to x equals 5, so your functions need to be in terms of y. So we're going to have to solve y equals x squared for x. Alright, so we're going to go ahead and just sketch that region again. So we're going to go all the way out to 5, because that's what we're going to rotate around, x equals 5. Go all the way up to 9. And then just a rough sketch here. So roughly that's our figure there. Okay. Rotating around x equals 5. Okay. We're going to determine our inner radius and our outer radius. Okay. So our inner radius, which is a function of y, so it'll be r sub y. Notice that it is constant no matter where we are, and it's a constant distance of 5 minus 3, or 2. So the inner radius is 5. Okay, oh, sorry, 5. It is 5 minus 3, which should be 2. Why did I say 3? That's a good question. This should be 2. So let's go ahead and fix this. Okay, all right, there we go. Now, the outer radius is going to be a little trickier to figure out. Okay, so we need to solve first y equals x squared. We need to solve that for x. So take the square root, don't forget your plus or minus. So plus and minus the square root of y is equal to x. So on your parabola, the right side of your parabola is going to be the square root of y, and the left side is going to be negative square root of y. Okay, so we are using the positive square root of y because we're looking at quadrant 1. Okay, square root of y, x equals the square root of y. Okay, so here's your inner radius. Your outer radius there. Okay. All right. So x equals the square root of y. That tells us this distance right here. That tells us this distance here. What we want is this distance here. Okay. So we want this distance. So if we say 5, that's going to give us this distance here. I don't want quite 5. I want 5, and then I want to subtract this out. So what is that? That's the square root of y. So that's how we figure out our outer radius. Okay, so outer radius, r of y, is going to be 5 minus the square root of y. Okay. Now when we go ahead and do our volume, our limits of integration are going to be in terms of y this time. We're integrating with respect to y. So the volume is going to be pi, integral from 0 to 9, okay, outer radius squared minus inner radius squared. Let me make sure that I put 2 in this time. Okay, good. I accidentally wrote 3 earlier. Okay, and then we'll go ahead and work that out. So we're going to square, so it's going to be 25 minus 10 square root of y, which is this y to the 1/2. Square root of y times square root of y is just y, and then minus 4 dy. Okay, 25 minus 4 is 21. So when we integrate 21, it's going to be 21y minus 10 to the 3/2 divided by 3/2 plus y squared over 2 evaluated from 0 to 9. So pi and then 21 times 9 minus, okay, go ahead and flip that 3 over 2 to become a 2 over 3 times the 10, which gives us 20 over 3 and then y is 9, so 9 to the 3 halves, plus 9 squared over 2. Okay, so pi times 180 minus, 21 times 9 is 189. 20 over 3 times 9 to the 3 halves power is going to be 180, plus 81 over 2. So it's going to be 99 pi over 2 after we get a common denominator of 2, and this is going to be approximately 155.5 units cubed. Okay, and I have one more video that's going to go through the other 2 examples that we have on the notes. Okay, so we'll see you next time.